What is the main problem addressed by the proposed method in the paper?
The main problem addressed by the proposed method in the paper is how to prevent model collapse through data selection when training new models with synthesized data. The paper focuses on the importance of not only having a high-quality generator, but also utilizing a high-quality verifier to select the data for training. The method aims to overcome the risk of model collapse, where training on synthesized data leads to a drop in model performance, ultimately resulting in dumber models. By leveraging feedback from a verifier to reinforce the synthesized data, the paper demonstrates through theoretical analysis and empirical experiments that data selection with a high-quality verifier can prevent model collapse and improve the performance of models trained with synthesized data.
How does the proposed method work, and what are the theoretical underpinnings behind it? Illustrate step by step.
The proposed method works by leveraging feedback from a verifier to reinforce synthesized data in order to prevent model collapse. The process involves training a generator to create synthesized data, which is then evaluated and pruned by a verifier based on its quality. The verifier selects high-quality data points, which are then used to train downstream models. The key theoretical underpinnings behind this method lie in the analysis of the impact of the generator and verifier on the performance of the final trained model. The theoretical framework considers a linear model and Gaussian mixtures, where data selection with reinforcement is modeled as a pruning strategy over synthesized data. The method aims to identify a sharp phase transition point where the downstream model's accuracy switches from being perfectly accurate to perfectly inaccurate based on the level of errors in the synthesized data and the parameters of the pruning strategy. The theoretical analysis provides insights into how the generator and verifier affect model performance, particularly in the infinite sample limit. By using reinforcement methods and high-quality selection criteria, the method aims to surpass the quality of the original data that trained the generator and prevent model collapse. The experiments conducted, including simulations, arithmetic tasks with transformers, and news summarization with large language models, demonstrate the practical implications of the theory and showcase how data selection with reinforcement can lead to improved model performance and prevent model collapse.
What are the theoretical or practical benefits of using data selection with reinforcement in preventing model collapse, according to the paper?
The theoretical benefit of using data selection with reinforcement in preventing model collapse, as outlined in the paper, is that it allows for achieving optimal performance in the high-dimensional limit with unlimited access to synthesized data. The paper demonstrates that as the number of synthesized data points approaches infinity, a model trained on selected data can achieve optimal results, on par with training on the original data. This is crucial in preventing model collapse and ensuring that the downstream model does not suffer from deteriorated performance due to training on low-quality synthesized data. Practically, the paper shows that using data selection with reinforcement, particularly with oracle supervision, leads to improved performance compared to relying solely on generated data. The experiments conducted in the paper, such as training transformers on an arithmetic task and news summarization with large language models, illustrate that oracle supervision can match training with original labels, surpassing the performance of the synthesized generator. This practical benefit ensures that the model does not collapse and continues to scale up effectively with synthesized data, ultimately improving model performance and avoiding the risk of dumber models resulting from model collapse.
How was the model validated or tested in the paper's experiments?
The model is validated or tested in the paper's experiments through various methods. In the experiments, the model is trained on synthesized data generated by a generator and then tested using different selection strategies with a verifier. The experiments include simulations on synthesized data, training a transformer on an arithmetic task, and fine-tuning Llama 2 on a news summarization task. The model's performance is assessed using metrics such as test accuracy, Rouge scores for news summarization, and prediction accuracy for arithmetic tasks. The experiments compare the model's performance when using different selection strategies, including oracle selection, weak supervision, and self-selection. The model is also evaluated by comparing its performance with the synthesized generator and the original dataset. The experiments demonstrate that using a high-quality verifier for data selection can prevent model collapse and improve the model's performance beyond training with the synthesized generator alone. The validation of the model's performance is crucial in showcasing the efficacy of using reinforcement and selection techniques to enhance training with synthesized data.
What are the specific results achieved with the proposed method in the experiments described in the paper?
The specific results achieved with the proposed method in the experiments described in the paper include the following. 1. In the arithmetic task experiment with transformers, data selection with an oracle verifier led to optimal performance, matching training with clean data and achieving Bayes' optimal accuracy. Weak supervision resulted in poorer performance, with a sweet spot where using weak supervision improved accuracy before degrading it with selected erroneous points. 2. In the news summarization task with Llama 2 to 7b and Llama 3 to 8b, using an oracle for selection yielded the best results, surpassing the performance of the generator in all settings. Even with only 1/8 of the data and training compute, the dataset curated with an oracle verifier outperformed the model trained with 100% of the training set and original labels. 3. Self-selection surprisingly led to better performance than the generator in the news summarization task. The fine-tuned Llama 3 model, despite having higher performance than the generator, showed performance similar to random selection, indicating that a verifier model with higher performance is not always better. 4. Increasing the number of beams in the arithmetic task experiment consistently enhanced performance, as the quality of the selected synthesized data improved. Using reinforcement methods for data selection and label selection showed considerable improvement compared to using the generated data without selection, mitigating model collapse. 5. The experiments demonstrated that the proposed method of leveraging feedback from a verifier for data selection can prevent model collapse and improve the performance of models trained with synthesized data.
What are the limitations or drawbacks of the proposed method according to the paper's findings?
The limitations or drawbacks of the proposed method according to the paper's findings include the focus solely on data selection as a means of data curation, neglecting other methods such as data augmentation, data regeneration, and weighting. The paper acknowledges that data curation encompasses more than just data selection, and suggests that exploring general data curation methods to prevent model collapse is an area for future research. Additionally, the experiments did not consider the impact of prompt engineering on the generator, which could significantly enhance the quality of data generation. The paper indicates that prompt engineering could be beneficial for synthesized data according to theoretical predictions. Therefore, the limitations of the proposed method include the narrow focus on data selection and the lack of exploration into other data curation methods, as well as the omission of prompt engineering's potential impact on data quality improvement.